Alright, this lesson is for Geometry 3.6, parallel lines in the coordinate plane. We're going to have a warm-up today. Alright, and the warm-up says, state whether the slope of the line is positive, negative, undefined, or zero. So the first one was rises from left to right. So if a line rises from left to right, it has a positive slope. A vertical line, which is straight up and down, has a slope that is undefined. So the right word that we're going to use is undefined. A horizontal slope has a slope of equal to 0, so kind of like the floor. Usually the floors are very level, so it's not tilting one way, left or right, so it has a slope of 0. And then falls from left to right has a negative slope. A lot of people get vertical and horizontal slopes mixed up. So vertical slopes are undefined, horizontal slopes are equal to 0. So that was our little warm-up today. Then we spoke about slopes of parallel lines and slope in general. So if two lines are parallel, then they have to have the same slope, right? So in the coordinate plane, what that looks like, it looks like this. So we had two examples. If I give you y equals 2/3 x plus 1, and put that onto the graph, that'd be the red line here. 2/3 x plus 1 is this red line. And then y equals 2/3 x minus 4 is this blue line down here. You can see that these lines are parallel, right? No matter where we go in the coordinate plane, no matter where we go, they will always be parallel. So, I can zoom in or zoom out, or it doesn't matter, right? There will always be parallel. They will never ever intersect. And no far how, doesn't matter how far out I go or how in or how close I get, right? They will never ever touch. That's what parallel means. Okay, so then we had a question. It says, are these lines parallel? How can you tell? Well, we reviewed the other day that given a line in the equation of the form y equals mx plus b, the m represents the slope in this case. So for us, in this particular problem, I have a slope of 1/3 in this equation, in this line. I have a slope of 1/3 in that line, right? So I can say because the slopes are equal, they must be parallel. So that's how I can tell, because the slopes are equal, and that's what it says up here, right? If two lines are parallel, then they must have the same slopes. So if their slopes are equal, then they must be parallel. The converse is also true. Okay, so number 3, here we go. Can you find the slope of a line that passes through the point 0, 6 and 5, So in order to get this one right, so we introduce the slope formula. Okay, again, given any 2 points in the coordinate plane like x1 and y1 and x2 and y2, the 2 random points in the coordinate plane, you can find the slope of those 2 points by this little highlighted formula here. The slope is y2 minus y1 over x2 minus x1. So in our case, right, we had this 0 represents x1 and this 6 represents y1. 5 represents x2 and 2 represents y2. So this is like my first set of numbers in the coordinate plane, and this is my second set of numbers. You can think of it like that. So to plug this into the formula, y2 minus y1, so that's going to be 2 minus 6. So 2 minus 6 is -4. And then over x2 minus x1 is going to be 5 minus 0. So I get a slope of -4/5. And we can also prove that on the graph as well. So I'll draw a graph here for you, and we can find these points on the grid. So let's zoom out and zoom in here. Let's see here. What can I do on this? I can go back like this, like that, right? Okay, good. So let's put the point 0, 6 on the graph. Here's the point 0, 6. And let's put the point 5, 2. So go over 5 and go over 2. Okay, and then you got to ask yourselves, how do I get from this line? What is the slope of this line? That's what I'm trying to figure out. Well, I can go down 1, 2, 3, 4, and I can go over 1, 2, 3, 4, 5. So I went down -4 over 5. So the slope is the change in y over the change in x. That's what this fraction says, right? Change in y over change in x. So the slope is going to be -4 over 5, which is exactly the same thing that we got down here. So these two things match up perfectly. Oh, I just erased my graph. There you go. There it is. Okay, so let's talk about the general form, right? Are these lines parallel? How can you tell? Well, unfortunately, these are not written in y equals mx plus b form, right? So they don't look like y equals mx plus b. So we need to change that. So here's what we're going to do. We're going to simplify this. So I'm going to solve for y. So 5y is equal to negative 4x plus 2, and then divide by 5 everywhere, divide by 5, divide by 5. So I get y is equal to a negative 4/5 x plus 2/5 for that one. Over here I could say 4y is equal to negative 5x plus 3. Divide by 4 everywhere. 4 divided by 4. So that means that y is going to be negative 5/4 x plus 3/4. And then let's take a look at their slopes, right, now that I can identify them. This slope for this line is negative 4/5. This slope for that line is a negative 5/4. They are not the same thing. Negative 4/5 does not equal negative 5/4. So therefore, these lines are not parallel. And I don't even have to graph them. I can just already tell. Or not parallel, use the symbol for parallel. So those lines are not parallel, and the way that I can tell is because their slopes are not equal. Okay, that's the fourth box there. Okay, let's go ahead and write to equations. Here's the equation of a line, y equals negative 2x plus 5. Can you find the slope of a line that would be parallel to this line? Well, any line that is going to be parallel to this line has to have the same slope. And in this case, I can see right away the slope of this line is negative 2. So for me, if I could find a slope of a line that would be parallel to my line up there, it would have to have a slope of negative 2 also. Okay, so far so good. Then it says, okay, can you find the equation of a line that's parallel to my line and make it pass through the point 4, 0. So now that I have the line, or the slope that's parallel, I'm going to start with that. I'm going to say, okay, y is going to equal mx plus b. The slope that I want is negative 2 to be parallel, so negative 2x plus b. And then I need to figure out what b is, so I'm going to plug in the points. This is x and this is y, always ordered pair. So I'm going to plug 4 in for x and 0 in for y and find my equation. So 0 is going to be negative 2 times x, which is 4, plus b. So 0 equals negative 8 plus b, so therefore b must be equal to 8. So putting this all together now, I can have this equation. Y equals my original slope, which is negative 2x, and then b is plus 8. Okay, so I found y equals negative 2x plus 8, and this one was y equals negative 2x plus 5. Let's graph both of those and see if they're parallel and goes through the point 4, 0. So I had y equals negative 2x plus 8. And the other one I had was y equals negative 2x, what was it? Plus 5. Plus 5. Okay, so let's graph this line, and let's graph this line, and let's take a look at them. Well, they sure do look parallel. The only question is, does my line, which was negative 2x plus 8, go through the point 4, 0? So let's zoom in and move over. Yep, it sure does. Right there, my line goes through the point 4, 0 and is parallel to the original line, which was negative 2x plus 5. So I know I did it right. Okay, and then we had some graphing on graph paper. So graph the two equations below on graph paper with your ruler. Okay, so are they parallel? How can you tell? So here's how you would do that, right? So I'll make a nice coordinate grid for you guys here. Okay, so let's go graph y equals 3x minus 2. So what we would do is we would go down to negative 2, which is the y-intercept, and then we would go up 3, 1, 2, 3, and over 1. And we would draw a line with a ruler, which looks much better than that one right there. And then for this one, right, we have to, this is not in standard form, so or slope-intercept form, so I can make it into slope-intercept form. So I can just change that real quick and say 3y equals 9x plus 15. So therefore, y is equal to 3x plus 5 when you divide both sides by 3. So in this case, I'll go up to 5 now, so I had to move my graph around. Let's go up to 5. And then the slope is going to be up 3 and over 1. So from there, I need to move my graph around a little bit more here. There we go. So let's go here. Start at 5, and then go up 3, 1, 2, 3 over 1. Put another line there, and then I've got my graph here like so. So there are my two graphs. They're not very pretty, so I'm going to make them a little bit more pretty by putting them actually on the line. There's that one, and then there's that one. There we go. That looks a lot better. And those lines are definitely parallel, and how can I tell? Because they have the same slope. The slope here is 3, and the slope here is also 3, so I can tell that they are parallel. Okay, that's your lesson.